I'm Austin Gaghan, and I am doing my individual presentation on the sensory and statistical evaluation of hard apple ciders. So to begin, in a little bit of introduction, hard apple cider is a very up-and-coming industry that is quickly expanding, and in the future will need a lot of extensive amounts of sensory evaluation in order to further the industry and understand what people are liking, what they are looking for in hard cider, and what is selling among the hard ciders that are already currently on the market. The purpose of this study was to establish if relatively untrained panelists could be used to evaluate the complex sensory qualities that come with a beverage such as hard apple cider. This study was conducted over two separate sessions, one training session and then the actual evaluation session. And 4 hard apple ciders were used to be evaluated, and there was 4 controls used as standards to give us an idea of how each panelist relatively experienced each of the tested attributes. Continuing with the purpose of the experiment, the training of panelists can be extremely expensive and require large amounts of time. So this study was conducted to evaluate if relatively untrained panelists can be used to study the qualities of a complex beverage such as apple cider, and if untrained panelists can be used for something more than just likability testing or differences from control testing, if a company was adding a new ingredient to the current recipe, or if they want to see if a new product is significantly different from their current product. There were 4 different attributes tested in this study: sweetness, dryness, effervescence or carbonation, and apple flavor. There were 4 controls that were used as a standard for each one of these attributes: apple juice for sweetness, Chateau Ste. Michelle Dry Riesling for dryness, generic brand lemon and lime soda for effervescence, and Angry Orchard crisp apple cider for apple flavor. There was also 4 different ciders that were used as the actual samples in the experiment: Smith & Forge hard cider, Square Mile hopped hard cider, Crispin English style hard cider, and Rambling Root hard cider. These 4 different samples were used because they're all pretty different. Smith & Forge and Rambling Root are fairly similar. They're more traditional American style hard ciders, but Square Mile is hopped, which grants a very different flavor profile than what is usually expected from a hard cider. And the English style Crispin cider was very dry, had very low amounts of residual sugar, and thus allowed for us to evaluate 3 different styles but 4 different samples. Both the controls and the evaluated samples were given random 3-digit codes and were presented in random orders as to reduce the amount of error in the experiment. During the training session, all of the panelists were screened for their ability to participate in the study. All of their ages were determined from their driver's licenses. They were asked if they were healthy, looked to see if they were showing any kinds of cold or flu-like symptoms. They were also asked if they had smoked or drank recently, which would confound the results of the experiment. And they were also asked how often they consumed cider in general, which was very low for pretty much everyone who participated in the study. Most people said that they drank beer or hard liquor such as whiskey and vodka. The experiment was also explained on how it was going to be conducted and what was expected of each of the panelists, and any questions they had were answered. The panelists at this point in time were also taught how to use all the ballots properly, and once they had been cleared for participation in the study, they were allowed to test the controls and taste and rate the 4 different controls on one of the 4 corresponding attributes. Water was given in between every sample as to wash out their mouth and not have the flavors conflicting. And after each of the controls was evaluated, the panelist was asked to come in for the next session and evaluate each of the 4 different samples on all 4 of the separate attributes. As can be seen on this next slide is an example of the ballot that we gave with the random 3-digit code at the top and a 15 centimeter line down below where the panelists marked a perpendicular line through the intersecting the blue line, giving us a relative idea of from low to high where the intensity of each of the four attributes was. Based on where the panelists marked, their line of intensity on the line scale was measured and then divided by the total length of the line to give what we titled an intensity ratio, which basically gave us a decimal point from 0 to 1 of where that panelist rated that specific sample, which we then used to create graphs and get averages and everything instead of just rating it on a scale of low to high relative intensity. We actually got some numerical data, which could later be used to evaluate statistically. This graph represents a plotting of all of the attribute scores using the intensity ratio for the crisp and English style apple cider. As you can see, the data is all over the map. Different samples ranging between 0.1 in intensity all the way up to 0.6, 0.7, depending on the panelists that interpreted it. As you can see, between panelists 1 and 2, sweetness drops from 0.75 about all the way down to about 0.15, which is an enormous range to have for a standardized sample. You can also see a lot of panelist error that was made throughout this graph. For example, panelist 11 and panelist 20, you can see the error of habituation, which shows that these panelists tended to grade everything on a similar part of the scale. In the case of panelist number 11, it seemed that almost 3 of the different attributes were all marked around the 0.4 range, whereas in 20, all of the attributes except for 1 were ranked between the 0.05 to the 0.15 range, which is extremely low. The panelist 11, you can also see the error of central tendency, where the panelist used basically only the middle of the line scale for all of the different attributes. There was a huge amount of error that occurred during this study. One such error was the halo effect, which is the rating of one attribute tends to influence the rating of other attributes that are associated in the mind of the panelist. So sweetness and apple flavor might have been misconstrued together, causing them to both be rated higher or lower depending on where the panelists thought that one or the other landed. The opposite of this is the Horns effect, where if there is something that is negative in the mind of the panelists, then they tend to rate other attributes as lesser or more towards what they think of as negative, causing a skewing of the results. Also, due to the fact that we didn't have proper facilities, mutual suggestion most likely occurred between the panelists. They did not have any kind of dividers in between them. While they were receiving random samples in a random order, and every one of them got different orders, there was still that they could see the other panelists' samples and they could see the other panelists' ratings of the samples. Also, there might have been a possible taste adaptation error that occurred due to just a lot of samples that shared a lot of common traits. While there was only a small number of samples and water was given in between each of the samplings, it could have occurred just due to the fact that there was a lot of tasting going on in a very short amount of time. In conclusion, trained panelists are definitely needed to correctly and reliably give results on the intensities of attributes, especially within a complex sample such as hard apple cider. With alcohol being a confounding attribute in there, it can make other things difficult to detect. Also, untrained panelists should only be used for things like difference testing and likability testing for consumer advice or new product design or something along the lines of that nature. They definitely cannot be used for a test such as this. As you could see from the graph earlier, the results are completely unreliable, inaccurate, and just all around unhelpful for discerning the physical attributes of these samples. Then that graph was not an anomaly in any way, shape, or form. All the other graphs that we had looked exactly like that, just sporadic and all over the place. So trained panelists are most definitely needed and required and well worth the money and